同学们好，本课程是针对研究生的全英文课程，知识发现与数据挖掘，建议每周学时4学时，在8周内完成本课程的学习。本课程内容是关于数据挖掘的，并且侧重于大量数据的挖掘技术。那么很多具体的例子呢，都是来源于Web 以及 Web 上的真实数据。本课程的主要内容包括分布式文件系统和 MapReduce 作为一种工具，它的在大量大数据运行上的一个并行算法。第二呢，包括一些相似性搜索的算法，其中比如 Min Hashing 和局部敏感的 Hashing 算法的关键技术的介绍。第三，本课程将针对快速到达的数据流的专门处理算法呢进行介绍。第四，介绍典型的搜索引擎技术，包括谷歌的 PageRank、链接垃圾的邮件检测，以及极限器等权威算法的介绍。第五，频繁级的数据挖掘，其中包括如何运用关联规则Market Basket 算法以及鲜艳算法的介绍以及改进。下来呢，我们还将对大规模的高维数据集的聚类算法进行介绍。那么聚类算法的目的呢，就是说把大量的相似性的数据呢先聚合在一起，从中发现其中的共同的规律。第七，将对超大图数据进行一个挖掘，因为超大图呢是社会网络图的一个典型的特征。那么对于这样的对于普遍存在的社交网络的结构分析和挖掘算法呢，对于理清网络中的关联信息和挖掘潜在的脉络都有非常的重要的意义。接下来呢，本课程呢将介绍大数据集合里面的降维技术，就是说把高维数据几千维甚至百万维的技术呢的维度呢降低到有效的若干维度，这样呢可以有效的减少数据的计算压力，以及更快的呈现出数据所体现出来的重要属性。那么典型技术呢，包括机异值分解和潜在语义检索技术。最后呢，本课程将覆盖一部分机器学习的算法，因为机器算法呢可以被广泛的应用到探索对大量未知数据的检测和处理过程中去。那么典型算法呢，包括感知机和直指向量机以及梯度下降算法等。这个呢就是本课程的一些主要内容。因为本课程呢是全英文课程，所以呢后面的 PPT 呢和讲解呢，我基本上都会用英语来进行。So the textbook of this course is called Mining of the Massive Dataset, coming from 3 professors of Stanford University. So, shall we start with the first topic? What is data mining? How can we implement knowledge discovery from data? The most commonly accepted definition about data mining is the discovery of models for data. A model sometimes can be one of several things. Some typical things might including for example, the statistic models, and probably also including some dynamic processing models as well. For example, the machine learning model. Why the data mining has becoming more and more important? This is some important figures to illustrate the use of electrical devices, which has bring us more and more data which has been collected from the web and also communication networks. Meanwhile, more and more enterprises and organizations has realized that data contains much more values and knowledge which will contribute for the future research and industry productions. So as a conclusion, the data is power, and also it's a power in the future. So in this aspect, the data mining is kind of technology regarding how to extract the knowledge from the data needs to be, and how it can be, for example, how the data can be stored and managed, and especially how the data should be analyzed. This is the purpose of this class, to help people to understand the data and to reveal the true value and the treasure from the amount of data. In the meantime, the data mining has quite a few synonyms regarding the big data, predictive analytics, and data science. As the demand for the data mining has been increasing for decades, from this figure we can find out that the demand for the deep analytical talent in the United States, which has been increasing from 80 to 60% than it ever before, and also especially there is a big talent gap. In 2018, it's about 140 to 160% increasing in supplement. Okay, and it will be becoming more requirement in the years later than 2018. So anyway, the good news is that if we focusing on the data mining aspect, probably we will get more good job positions in the industry market. So let's go back to the true topic. What is data mining? The data mining has a prerequisite that we have a lot of data, and there are also some requirement will help us need us to find the patterns. The patterns, you can think about some disciplinaries and the regulations and the rules which can be applied further into the future data. And also including the models which are used to analyze the continuing production data as well. So in this aspect, the data mining technologies has 4 typical features. For example, the data should be valid in the new data holding and with some certainties, and also the actions should be, or algorithms should be useful to be put on the data analysis. As for the data system, there we probably will review unexpected, such as not so obvious results to the system, and the result and should be interpretable to the humans. Anyway, should be understand to the humans. About the data mining, we will cover the following aspects. The first aspect is the statistical modeling. I do the statistical modeling is the statisticians probably were the first to use the term of data mining. For example, they are using the data mining and data dredging, as the dredgery terms refer to the attempt to extract information from what is supported by the data. Okay, and also the statistical persons are using the data mines as the construction of statistical models. That is, try how to understand the underlying distribution disciplinaries to analyze the further the coming results as well. Okay. As the second part is the machine learning. There are some also the question is that about the data mining appropriately using the algorithm from the machine learning. The machine learning practitioners are generally using the data as a training site to train an algorithm, or one of the many times used by machine learning practitioners. The typical algorithm might include the Bayes network, support vector machines, and distribution trees, and hidden Markov models, and many other relevant algorithms as well. There are also some situations more suitable for in the machine learning case. The typical case is that the machine learning is a group approach, especially when we have little idea about what we are looking forward in the data. For example, it's rather unclear that what it's about the movies that make certain movie goers like or dislike it. Thus, the answer is that how to discover the algorithm to predict the rating of movies by the user are really based on the example of their responses. So the machine learning algorithm will and actually have been proved much successful than other algorithms as well. On the other hand, the machine learning has not proved successful in the situations that especially where we can describe the goals in the data mining more directly. So the interesting part is that when we're trying to analyze unpredictable data, probably the machine learning is a good approach. Well, if we have clearly descriptions about the data and the analysis target, well, other which might be the pitfalls for the machine learning algorithms. Okay, so the third part is the computational approach to modeling. Most recently, computer scientists have looked at the data mining as an algorithms problem. In this case, the model of this data is simply the answer to a complex query about it. For example, given the set of numbers, we might compute their average standard deviations. About these values might be or might not be the parameters of following the Gaussian that best fits the data, although they will also certain about the very close disciplinaries as well. Okay. As to the fourth, the summarization is a very useful task for the data mining. One of the most typical technology is PageRank. Well, before the PageRank, it had been becoming the most successful search engine of Google. The summarization might be trying to clustering the more similar and targeting the most important similar things to find the to reflect the most important or similar things together and to summarize typical disciplinaries as well. Okay. As to typical instances about the summarization, and in the summarization there is an important form of summary, the clustering. The clustering, which might be covered in chapter 7, and here the data as like these slides is viewed as points in multi-dimensional space. Point out that all the points close to the space are assigned with the same cluster, and all the clusters themselves are actually summarized by giving the centroid of the clusters and also the average of this the average of this distance to the junction of the road can be put into this this figure. Okay. So this figure actually reveals the outbreak of cholera in London, which shows a little illustration that the precise is happens much more closer to the sites where the wells are. So in that case, this gives us some indications that the cholera is broadcast from the water. Okay. As for the fifth job of the data mining is about feature extraction. The typical feature-based model looking for the most extreme examples of this outside of some phenomenon, and so as to represent the data by these examples. If you are familiar with Bayesian networks, which is a branch of machine learning and also a topic we shall cover in the next in the following chapters of this book, we will probably understand that this is a complex relationship between the object is represented by finding the strongest statistical dependencies among this object and using only those in representing all statistical connections. Some of the important kinds of features extractions from large-scale data we shall study, including how can we find frequent item size. This model will make sense to the data that consists of a basket of small set of items, such as the market basket problem that we shall discuss in chapter 6. We in this job, we are looking for the small set of items that appear together in many baskets, and all these frequent item size are the characterization of the data that we seek. The original application of this sort of mining was through market basket, while the set of items such as hamburger and ketchup and tissues are the real merchant the people are trying to buy together when they were checking out at the cashier registry in the store or the supermarket. And also we need to sort out the similar items. Often your data looks like a collection of sets, and the objective is to find pairs of sets that we shall have a relatively large fraction of their elements in common. An example is treating the customers like online store like Amazon as a set of items they might have bought. In order for Amazon for recommend something else, they might, like Amazon, are looking for the similar customers and trying to recommend something many of these customers might have bought. This process is called collaborative filtering. We will be discussed in the chapter 6 as well. So if the customer are single-minded, that is, they bought only one kind of things, then clustering customers might work. However, since customers tend to have interest in many different things, it's more difficult to find for each customer a number of other customers who are similar in their taste, and to represent the data by these connections. Okay. So based on the above analysis, the data mining tasks can be classified into descriptive methods, which are used to find human interpretable patterns to describe the data. For example, the clustering, the proper data points to find the potential clues of the gathering. And the second is the predictive methods, which uses in some variables to predict unknown or future coming values of other variables. For example, the recommender system sometimes is also called recommendation systems to reveal the potential customers or buyer for a specific merchandise. As we know that the first people applying the data mining technology is statisticians. There are also some statisticians to review the unusual event hidden within massive amount of data. So the risk with data mining is that the analyst can discover patterns that are meaningful and also meaningless. So this phenomenon is called Bonferroni principle. The Bonferroni principle is talking about the total information regarding the total information awareness as well. The total information awareness was eventually crossed by concern, which that might look like much data, and you're trying to find within these activities that we might influence or might not influence the actual results. As to the Bonferroni principles, suppose we have a certain amount of data. If you are trying to looking for events of a certain type within that data, you might expect events of this type to occur. Even if the data is completely random and the number of occurrences of these events will grow as the size of the data, you might not have to these occurrences are sometimes called bogles, in the sense that they might have no cause other than the random data will always have some number of unusual features that are looking for significant results as well. So this theorem is a statement of the Bonferroni correction, which gives a statistic sound way to avoid most of this bogus positive response to search through the data without going to the details. We probably will uncover several trick informations. Okay. For example, if we try to find some people unrelated who at least twice has stayed in the same hotel in the same day, this might be based on the tasks that if we try to identify who are the potential terrorists. In that case, we will trying to track about the 10 with the power 9 people in the world, and the time span might cover the 1,000 days, and also each person they stays in the hotel 1% of the time, and if a hotel hold 100%, we probably need 10 with power 5 hotels. Suppose everyone behaves randomly, how will the data mining detect anything suspiciously, especially in a limited time span? So, based on the above figures, we can get the estimated results that we will identify 250,000 people which might be suspicious. In the meantime, there are too many combinations we need to check. Actually, we have no such much labors to apply such identifications. Okay. So in that case, we need more additional evidence to locate more suspicious pair of people, and in some more efficient manners as well. Now, here is something useful we need to know before this course. The first is the TF-IDF measure of the word importance. Okay. The importance of word in the document. In several applications in the data mining, we shall be faced with the problems of categorization document using sequence of words by their topic. Typically, topics are identified by finding the special words that characterize document about that topic. For instances, articles about baseball would tend to have many occurrences of words like ball, bat, pitch, run, and so on. Once we have classified documents to determine they are about baseballs, it's not hard to notice that the words such as these appear unusually frequently. However, until we have made this classification, it's not possible to identify these words as characteristics. In such situation, classification are also often started by looking at the document and finding the significant words in this document. The first guess might be that the words appear most frequently in the document are the most significant ones. However, the situation is exactly opposite to the truth. The most frequent words will most surely be the common words, such as the articles like the, and, which help building up ideas but do not carry any significant information themselves. In fact, the several hundred most common words in the English, sometimes we also call stop words, are often removed from document before any attempt to classify the document themselves. So in fact, the indicators of the document are relatively real words. However, not all real words are equally useful as indicators. There are certain words, for example, notwithstanding or albeit, that rarely appear in the collection of documents. So here is a formal measure of how can we locate and concentrate into relatively few documents that the occurrences of given word is called a TF-IDF. A TF means term frequency times. IDF means inverse document frequency. So these terms really means that the most frequently happened words are actually not happens in every document as well. So this is how the TF-IDF works. As to the example 1.3 in the textbook, you will understand how the TF-IDF parameters are used to identify the most important characteristics in the document classifications. Okay, so the second useful things we need to know is the hash functions. As we have already understand the hash functions in the data database and the data processing courses as well. So the hash function, it takes the hash key value as an argument and produces a bucket number as a result. So the two bucket numbers is an integer, normally in the range. So in that case, the hash keys can be any of these types as well. Okay, so the hash functions are useful. We can check out the examples about 1.4 from this type tools to understand further regarding these hash functions. Okay. So what if hash key are not integers? In a sense, all data types have values that are composed of bits, and the sequences of bits can always be interpreted as integers. However, there are some simple rules that might enable us to convert common types into integers as well. For example, if hash keys are strings, so the conversion of each character to ASCII or Unicode are equivalently, which can be interpreted as a small integer as well. So we can sum up the integers before dividing by the underscores as well. Okay. As for more complex types, we can also extend this idea using for converting these strings to integers as well. Also, the secondary storage are also very important for the running time of an algorithm, especially when we are dealing with large-scale data. If we have a good understanding of the differences in the time taken to the performance of computation, so the data is was initially resides on the disk, as opposed to the time needed if the data is initially in the memory. So the physical characteristics of disk is another subject on which we might have concerns about how it will affect the computation speed and could be the very important factors to affect the computation time. As we know, the hard disks are organized into different blocks or sectors, which are the minimal units that the operating system used to move data between memory and the disk. Okay. So, how to organize our data that is related to the relevant part is called a single cylinders. So if the cylinders are reachable in fixed radius from the center of the disk, and therefore we can read all the blocks on the cylinder into the memory in considerable less than 10 milliseconds per block. So you can assume that the disk cannot transfer data to memory as more than 100 million bytes per second, no matter how the data is organized as well. Okay. The next useful thing is based on natural logarithm, which are used to reduce the dimension from the high power to the logarithms. Some of these useful approximations follows is called Taylor expansion, which are used to lower the dimensions of computation and tasks into the multiplications rather than the power computations. The final useful thing is power laws. As we know that there are many different phenomena which might happen to the two relevant variables. In that case, we are trying to using the power laws to explain these phenomena. That is the linear relationship between the logarithm of variables, and also in the we might also examine the records from this Amazon that the power laws are really applied to the electrical products as well. For example, the Mathieu effect. The existence value of is exponentially higher than 1, examined by the Mathieu effect. In the biblical book of Matthew, there is also verse about the rich get richer. Many phenomena exhibit this behavior, where getting a high value of some property causes that very property to increase. For example, if a web page has many links in, then the people might have more likely to find the pages that may choose to link to it from one of their pages as well. Another example, if the book is selling well, then it might be likely to be advertised by more websites when customers going to the bookstore. Some of these people are trying to choose to buy the book as well, with increasing the sale of this book. So this is a Mathieu effect affected by the power laws. Okay, so the power laws, there are also many other ways to apply the power laws regarding the following phenomena. For example, we might to use to measure the node degrees in the web graph. We can order all the pages by the number of inlinks to that page, and also we can also try to using the power law to analyze the sales of our product, and also we can try to analyze the size of different websites as well. Okay. So the next topic is that we might concerns how many different information will affect the data processing as well. Okay. This is a three-dimensional map. This is three-dimensional, or you can call it like a cubic. We're trying to understand how the things relevant to the data. As to the dimension of data operators, we might concern or be challenged with how we collect the data, how we prepare the data, how we represent the data and build up the data model, the appropriate data model, and also including the proper reasoning algorithms and visualization manners as well. As to the data modalities, we will probably concern how we deal with the data, to treat the data like ontologies or the structured data or the networks or text, multimedia, and signals. So the data can be present in various models, which will affect the choosing of the proper algorithm and models for the data processing. So all the challenges we are facing is that we might facing the challenge about how we use the data and the quality of data, whether the quality has been mixed about many different noises, and also the data has its own context, how the data is produced, how the data is collected, and how the data will be applied and implemented in the appropriate tasks. And also, how can we dealing with the data streaming, which is unstoppable, and keep coming data, which give us a lot of tasks or pressure for data processing as well. And as we know, the data are becoming larger and larger, bigger and bigger. So in that case, the scalability of the data is also another challenge regarding the data storage and the data usage, and also the data algorithms as well. Okay, if you put all the issues together, we might think about the data mining cultures. As the data mining is a kind of area overlaps with the database processing, covering the large-scale data, simple queries, and also it has connections, much connections with the machine learning to deal with small data, with complex models, or even deal with large data with much simpler or much complex models as well. And also the data mining also concerns with computer science theories regarding the different or randomized algorithms as well. Data mining are also including different cultures. For a database person, data mining might be viewed as an extreme form of analytic processing, so that the queries can examine large amount of data rather than a single queries in the database. As to a machine learning person, the data mining task might look more like inference of models, which will present the result in the parameters of these models as well. So in this course, we will do both aspects to help students to understand, to have a comprehensive understanding regarding the data processing and the machine learning as well. Okay. As a small conclusion, this course will have some overlaps with the machine learning, with statistics, and also some algorithms regarding the artificial intelligence, databases as well. But I hope you don't feel much pressure from these topics as well. So we will concentrate on the data scalability and algorithm, computer architectures, and also especially the automation of handling large data. Okay. So what we will learn from this course. First, we will learn how to process different type of data. For example, the high-dimensional data, the graph data, the infinite, never-ending data like data streaming, the data with the labels. How can we label the data? We will also learn how to use different models to process different data. For example, how can we use the MapReduce? How we dealing with data streams and online algorithms, and also how can we process data with single machine in the memories. Okay. And we also will, from this course, we will also learn to solve the real world problems. As we know, only the real tasks from the real life will give us much more useful analysis as well. For example, we will illustrate how can we construct the recommender or recommendation systems, and how can we implement market basket analysis to find similar customers or buyer for a specific accommodation or merchandise. and also how can we detect the spams in the internet, and how to identify duplication of documents from the seas or mountains of documents as well. In the meantime, we also will have some knowledge regarding different tools like algorithm as well. We probably will recall some knowledge from linear algebra to grasp the SVD algorithm and the recommendation system and communication detections. And in the optimization aspect, we will have fully grasp about the stochastic gradient descent to find the optimized algorithm as soon as possible in a more efficient manners. We will also apply the dynamic programming to find the most frequent item size to identify the top cells, and also we can also apply the hashing technology to find the local sensitive hashing machine, and also to construct the Bloom filters as well. How can we put all this together? We can use this diagram to illustrate all the above tasks. For example, we can, in the high dimensional data processing, while including the local sensitive hashing technology, clustering, and the dimensionality reduction. In the graph data, we will have some hands-on experience in the page rank, scene rank, similarity rank, community detections, and span detections as well. For the infinite data, we will learn how to filter in data streams and web advertising, and how can we do the queries on the strings. Regarding the machine learning, we will understand the supporting vector machine, and how can we construct the decision trees, and also the very basic perception ideas, and also the KNN learning algorithms as well. As to the application levels, we will have a fully understanding regarding the recommender systems and the association rules to build up the connections between different items as well. In the text document processing, we will try to identify the duplicate text to, for example, to identify the plagiarism in the academic areas. Okay. Now, how do you want about data? This might be a cartoon to help you understand. Look at maybe we are the chef, and the data is the cooking material. How can we produce a delicious cuisine? Is really based on the technology we are trying to apply in the practical test, and probably which can be learned from this course. Okay, so this is the first chapter. Also, like regarding the introduction of this course as well. Okay, so that's for the first lecture. Okay, thank you.